In this video, we'll discuss balancing redox reactions in basic solution. So in class, we talked about balancing redox reactions under acidic conditions. The steps are pretty much the same, but there's one additional step for basic conditions. So I'm going to go through the steps quickly and review what we talked about in class, but then we'll do the last different step together. So remember, the first step when you're balancing a redox reaction is to assign oxidation states to every atom. So you need to look at your equations and assign your oxidation states. So the second step then is to separate your reaction into two half reactions. And those would be our reduction reaction and our oxidation reaction. Remember that we can't have one without the other. So one species will be reduced and the other one will be oxidized. You'll then balance each half reaction with respect to mass, so we have to have the same number of atoms on each side. There's my with sign. So for a lot of atoms, you're just going to put a number in front of them, but commonly you'll have to add oxygens or hydrogens. So we add H2O to add an oxygen atom, and then we add H plus to add a hydrogen atom. So if you need oxygens on one side of the equation, you'll add water, and that will be how you get your oxygens in there. And if you need hydrogens, you can just add H plus directly. So after you balance for mass, then you're going to balance for charge. So we'll say balance each half reaction, so my oxidation and my reduction reaction, with respect to charge. So that can be done by adding electrons, so that the charge on each side, the reactant side and the product side, is equivalent. When you've balanced each half reaction for charge, then you want to make the number of electrons in each equivalent to one another, so that when you add them together, those electrons will cancel out, since they'll be on opposite sides for the oxidation and the reduction reaction. So make our number of electrons in each half reaction, so my oxidation reaction and my reduction reaction, so that's a parenthesis, equal to each other. So I can do that by just multiplying if they're not already equivalent to one another when I'm done balancing for charge. And then the sixth and final step is to add the reactions together. So you put together the two half reactions, cancel out anything that is on either side, both the reactants and the products, and then you'll have your balanced chemical equation. So we're not going to go through all those steps here because we did it in class, but let's look at an example reaction where I have I minus aqueous plus MnO4 minus aqueous goes to I2 aqueous plus MnO2 solid. So this reaction is not mass or charge balanced right now, and I'm not going to do those steps, but you could do it by going through all the steps we talked about. So I'm going to just say charge and mass balance, and by doing that we would get a completed redox reaction that was charge and mass balanced, but because of the way we learned it, it would have H plus in that. So I'll write that on the next slide. So I'm going to write my mass and charge balanced equation here on this side. So that would be 6 iodide ions, aqueous, plus 8 H plus aqueous plus 2 MnO4 minus aqueous, and I'm going to do this, goes to 3 I2 aqueous plus 2 MnO2 solid plus 4 H2O liquid. So this equation is mass and charge balanced, but what you'll see is that I have H plus in solution. So this is under acidic conditions. And if I want to go to basic conditions, I'm going to add OH minus. And in this case, I'm going to add OH minus to each side of the reaction. And in this particular reaction, because I want to neutralize 8 H pluses, I'm going to have to add 8 OH minuses to each side. So we can say 8 OH minus aqueous to the reactant side, and I'm going to squeeze it in down here, plus 8 OH minus aqueous to the product side. So then what's going to happen is I'm going to make water from the combination of this H plus and this OH minus. So those are going to combine to make H2O liquid, and there will be 8 of them from the combination of those. And then I'm going to have water on one side and water on the other. So let's go to the next page and I'll write out what equation I have after adding the H plus to each side. So I now have 6 I minus aqueous plus, and I'm going to use that same green color, 8 H2O liquid. So that came from the combination of my hydroxide and my protons, plus 2 MnO4 minus, and that goes to 3 I2 aqueous plus 2 MnO2 solid plus 4 waters that I already had, so this is a 4, plus 8 hydroxides. So I took my formerly balanced chemical equation and I added my hydroxides, 8 of them to each side. They combined to make water, the hydroxides and the H pluses on one side, and then I added 8 to the other side as well. Now in this case I have 8 waters here and I have 4 waters here. So what's going to happen is these 4 waters are going to be canceled out and I will be left with 4 waters there. So we'll go to the next slide and then I'll write the total balanced chemical equation, which will be in basic conditions because we'll have this hydroxide minus in there, and then we can check for the charge and mass balance. Okay, so after canceling out my water, I now have 6 I minus aqueous plus 4 H2O liquid plus 2 MnO4 minus. I'm going to squeeze my aqueous in down here, and that goes to 3 I2 aqueous plus 2 MnO2 solid plus 8 OH minus aqueous. So now I am in basic conditions here, and for my check I've got iodine, hydrogen, oxygen, and manganese on each side. So it looks like I have 6 iodines on my reactant side. I have 8 hydrogens, and I have oxygens coming from 2 places. So there's oxygens in my water and oxygens in my MnO4. So I have 2 times 4 is 8 plus 4 more, so I have 12 oxygens. Then I have 2 manganese. So this is my reactant side. I'm going to check my product side. Again, I have 6 iodines from 3 I2s. I have 8 H's from my hydroxide. I have 8 oxygens from the hydroxide and 4 from the manganese dioxide, so that's 12. I have 2 manganese, and then I'm going to check for my charge. So the charge on the reactant side comes from these iodines and this MnO4 minus, and so that's a total charge of -8. And then on my product side, I also have a charge of -8 from the 8 hydroxides. So check, you have done it. You've now written out a balanced redox reaction under basic conditions.